Hi everyone, my name is Steven Simon from Food Technology course. Today me and my fellow friends will be presenting about a chemical compound that is widely used in food industry, which is sodium alginate. Sodium alginate is a linear polysaccharide derived of alginic acid. Sodium alginate is a cell wall component of marine brown algae and contain approximately 30 to 60% of alginic acid. Generally, sodium is made by the reaction of sodium carbonate with alginic acid. The conversion of alginic acid to sodium alginate allows its solubility in water, which assists its extraction. Sodium alginate have a European food additive number of E401. Sodium alginate is the main form of alginates used in food that can function as a thickener, stabilizer and gelling agent. This ingredient is commonly used to produce heat stable gels and to impart viscosity in food. The biggest advantage of alginates is its liquid gel behavior in aqueous solution. When monovalent ions are exchanged for divalent ions, the reaction proceeds almost immediately, changing from a low viscosity solution to a gel structure.
Good day to everyone. I am Kobinat Rao, and today I would be presenting about sodium alginate, or commonly known as SA, at a concentration of 0.2% to 0.5%, has been used as a thickener for neutral flavored milks such as chocolate milk. Besides, SA is also capable to form a smoother mixture, act as a clarifying agent, and as a stabilizer. In a study carried out, it was found out that sodium alginate in chocolate milk reduces glycemia and induces satiety. In the presence of calcium ions, SA forms a gel-like structure. However, with the correct concentration, SA acts as a thickener and as a texture improviser. Thank you.
Good morning to everyone, and I'm going to present about mechanism of sodium alginate to calcium alginate, which gives the gelling properties. Okay, first of all, the sodium alginate, which is NaC6H7O6, reacts with calcium chloride, which is CaCl2, to generate calcium alginate, which is C12H14CaO12, which is a gelatinous material. The two chemicals are rearranged, so they bond like the egg box model to form a gelatinous jello-like substance. Of all the different biopolymers that can be employed in the formation of the semi-permeable membrane in capsules, alginate is one of the most frequently used, owing to the fact that its immobilization is carried out under very mild condition. Okay, after this I'm going to present a video. In molecular terms, alginate consists of a family of unbranched binary copopolymers of 1,4-linked beta-diaminuronic acid, which is M, and alpha-gluuronic acid, which is B, of widely varying composition and sequential structure. Alginates are true block copopolymers composed of homopolymeric regions of M and G, which is termed as MM and GG blocks respectively, interspersed with regions of alternating structure, MG blocks. In solution, alginates behave like flexible coils. However, upon interaction with divalent metal ions such as calcium, they form an ordered structure, which showed that the gelation process involves cooperative binding of calcium ions between aligned GG blocks of two alginate chains. The gelation of calcium alginate is an almost instantaneous an irreversible process which is governed by the relative rate of diffusion of calcium ions and polymer molecules into the gelling zone. Thank you.
I would like to continue on the function of sodium alginates. Alginate, or more specifically sodium alginates, can be used as thickening agent, especially in dairy-based frozen products such as ice creams, yogurts, puddings, cheese sauce, and desserts. Alginates can form strong, cohesive, thermoresistant gels in the presence of calcium ions. The uses of sodium alginates are based on three main properties. The first is their ability, when dissolved in water, to thicken the resulting solution, more technically described as their ability to increase the viscosity of aqueous solution. The second is their ability to form gels. Gels form when a calcium salt is added to a solution of sodium alginate in water. The gel forms by chemical reaction. The chemical displaces the sodium from the alginate, holds the long alginate molecules together, and a gel is the result. No heat is required and the gel do not melt when heated. The third property of alginates is the ability to form films of sodium or calcium alginate and fibers of calcium alginates. Thank you.
Hello, I'm Tirushankari Moganasudaran. For the next part, let's look at the possible substitute that can be used instead of sodium alginate in chocolate milk. Carrageenan is an extract from a straight seaweed commonly known as Irish moss. This edible seaweed is native to the British Isles, where it's been used in traditional cooking for hundreds of years. It is also widely used in the food industry, mostly as a thickener or gelling agent. You'll find it in ice cream, cottage cheese, non-dairy milks, jelly, puddings, and infant formula. Unlike gelatin, which is made from animal products, carrageenan is appropriate for vegans. Carrageenan is by far the most commonly used stabilizer in chocolate milk that can be substituted instead of sodium alginate. Carrageenans are divided into two groups, refined carrageenan and semi-refined carragenate. Both types are applicable in chocolate milk. Carrageenans are further grouped into kappa, lambda, and lota carrageenan according to their chemical composition. It is especially in kappa carrageenan, which has found used a lot in chocolate milk due to its ability to react with the milk proteins and form three-dimensional network. The carrageenan forms a helix with a negatively charged sulfate group turning outwards. This helix interacts with the positively charged casein measure. When carrageenan is used as stabilizer, the chocolate milk must be cooled down below 25 degrees Celsius before filling or cooled down below 25 degrees Celsius during constant rotation if in can or in bottle sterilization is used.
My name is Mishantini Nair. I'm going to present about the application of sodium alginates. The first application is in textile printing. Alginates are used as thickeners for the paste containing the dye. These pastes may be applied to fabric by either screen or roller printing equipments. The second application is in food. The thickening property of alginate is useful in sauces, in syrups, toppings of ice cream. The addition of alginate also can make icings non-sticky. The third application is immobilized biocatalysts. Many commercial chemical synthesis and conversion they are using biocatalysts such as enzymes or active whole cells. For example, enzymes are used for the conversion of glucose to fructose, the production of L-amino acids for use in foods, and continuous production of yogurt. And the fourth application is pharmaceutical and medical uses. They have good wound healing and hemostatic properties and can be absorbed by body fluids because the calcium in the fiber is exchanged for sodium from the body fluid to give a soluble sodium alginate. Alginate is used in controlled release of medicine, drugs, and other chemicals.
In conclusion, every ingredient plays a specific role in every food. Thus, sodium alginate, which is extracted from brown seaweed, has multiple functions such as stabilizer, thickener, gelling agent, and many more. So, it could be a very good ingredient replacement in food which has absence of such qualities stated above. Thank you.